Space launch boosters send complicated spacecraft into resolute journeys about our planet.
We choose to go
Tranquility Base here. The Eagle has landed.
The Atlas was given the highest program priority.
Took a crisis, the space race.
The decade of so-called détente.
Houston, you're go for landing.
Over the last 50 years, Air Force space and missile programs have created amazing changes in the way the United States preserves the peace and, when necessary, fights wars. A technology explosion that past generations could only dream about has provided profound improvements in American military operations. This is the story of those 50 years. The military space age began with visionaries and air power pioneers such as Generals Hap Arnold and Jimmy Doolittle.
I feel that the same future exists for space that existed for the Air Force.
Immediately after World War II, while the Cold War threat from the Soviet Union was growing, studies for the Department of Defense confirmed that intercontinental ballistic missiles could be used to launch satellites. In 1954, the Air Force Missile and Space Program began. A converted schoolhouse in Inglewood, California, served as the modest accommodations for the Air Force's Western Development Division. The organization's first priority was to develop the Atlas Intercontinental Ballistic Missile, or ICBM. These missiles were needed to provide a strategic counterbalance to the Soviet Union's missile program. The Western Development Division's first commander was Brigadier General Bernard A. Schriever.
The Atlas, now called Weapon System 107A, was given the highest program priority in the Air Force.
The next year, the Air Force also initiated the design of the Thor Intermediate Range Missile. Later that year, military satellite projects were transferred to the Western Development Division, and the Atlas and Thor missiles were selected for modification to become America's first space launch vehicles. The shocking event that kick-started America's race to space occurred on October 4, 1957. The Soviet Union launched Sputnik 1, the world's first artificial satellite. The Soviets proved that they possessed the world's only successful satellite program and the potential to field an ICBM force. For the first time, America seemed vulnerable to an enemy missile attack. The U.S. Army launched Explorer 1, the first successful American satellite, in January 1958. A year after Sputnik 1, the Air Force successfully carried out its first orbital launch on an Atlas vehicle. Project SCORE was the world's first communication satellite. Its mission included broadcast of a recorded Christmas message from President Eisenhower to the world. The Air Force also developed the Advanced Reconnaissance System, which by 1959 had evolved into two programs to perform photographic reconnaissance, and another to carry out space-based missile warning. In 1960, Gary Powers' U-2 aircraft was shot down over the Soviet Union.
I ended up in an inverted spin with a lot of G-forces throwing me.
The nation's reconnaissance mission shifted to space alternatives. Discoverer 14 was the first satellite to return photoreconnaissance images from orbit. It photographed more Soviet territory than all earlier U-2 flights combined. The Air Force Satellite Control Network was developed to track and control satellites in orbit and process incoming data. The network included remote tracking stations around the world. Meanwhile, Air Force ballistic missile programs were rapidly evolving. Two new ICBM systems, Titan and Minuteman, had gone into development. In a few short years, 4 separate ballistic missile systems reached operational status. Soon, upgraded versions of Minuteman, along with the Titan II, which like Minuteman could be launched from hardened underground silos, became the mainstay of America's strategic missile force.
We choose to go to the moon in this decade and do the other things. not because they are easy, but because they are hard.
In 1959, the Air Force began developing man-rated launch vehicles for NASA to carry America's most precious cargo, her astronauts. NASA used the Atlas for its first manned space program, Project Mercury.
Godspeed, John Glenn. Roger, backup clock is started.
Soon afterward, the Titan II carried astronauts of the Gemini program into orbit, where they practiced docking with unmanned Agena target vehicles. This test of procedures and technology paved the way for Apollo missions to the moon.
Contact light. Okay, engine stop. Tranquility Base here. The Eagle has landed. Tranquility, we copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
NASA developed the highly successful Delta launch vehicle from the Thor missile. Beginning in 1960, Deltas launched payloads for many military and civilian space missions. In 1961, the Secretary of Defense gave the Air Force a near monopoly on development of military space systems. For large, heavy payloads, the Air Force developed the powerful Titan III booster, which in several configurations carried out a wide variety of missions for the next quarter century. During the 1960s, the Air Force developed valuable new satellite systems. The Defense Meteorological Satellite Program, DMSP, conducted weather observations required for photographic reconnaissance and other military operations. The initial Defense Communications Satellite Program sent both voice and photo data. These systems made their first major impact during the conflict in Vietnam. Vela surveillance satellites were launched to monitor other nations' compliance with the Nuclear Test Ban Treaty. Development of more advanced communication satellites led to the Defense Satellite Communication System, DISCUS. By 1982, DISCUS 3 satellites provided even more flexible communications coverage and resistance to jamming. Navigation using signals from satellites was another groundbreaking concept. The Global Positioning System, GPS, was initially designed to support military navigation of ships, submarines, and aircraft. However, GPS uses quickly spread to encompass a wide variety of military and civilian applications. In 1982, Air Force Space Command was activated with headquarters at Peterson Air Force Base, Colorado. The new Major Command gradually took over all operational space functions, including 2 launch ranges and 2 satellite control facilities. Cape Canaveral Air Force Station, Florida, is the launch range for placing satellites into equatorial orbit. Vandenberg Air Force Base, California, is ideal for launching satellites into polar orbit. This launch range also sends test ICBMs to target areas in the Pacific Ocean. The organization now known as the Space and Missile Systems Center, SMC, continued to develop and acquire satellite and launch systems. Located at Los Angeles Air Force Base, the center was the organizational descendant of the Western Development Division. In the late 1980s, most of the satellite control operations moved from the facility at Onizuka Air Force Base, California, to the Consolidated Space Operations Center at what is now Schriever Air Force Base, Colorado. By then, the Satellite Control Network's mission had expanded to control most DoD and some civil and allied nations' satellite systems.
Challenger now heading downrange. Challenger, go.
On January 28, 1986, the Space Shuttle Challenger exploded during launch, killing all 7 astronauts on board, creating a major crisis for America's space program.
Today is a day for mourning and remembering. Nancy and I are pained to the core by the tragedy of the Shuttle Challenger.
The shuttle program came to a halt while NASA investigated the cause of this accident. Military payloads awaiting launch on the space shuttle had to obtain launches on expendable Air Force boosters or be delayed indefinitely. The future of the space program was on the line. Fortunately, the Air Force had already started developing an improved, diversified fleet of expendable space boosters. The Titan IV became the nation's premier heavy-lift vehicle, capable of carrying 10,000 pounds into orbit. Deactivated Titan II ballistic missiles were converted into launch vehicles for smaller payloads. The Air Force also began development and production of 2 boosters for medium-weight payloads. Delta II launched all of the satellites in the first operational GPS constellation without a single failure. The Atlas II also had a 100% success rate with satellites such as Discus. Operation Desert Storm was the first major test of space support in a large military campaign. During the Gulf War, United Nations military forces, led by the U.S., operated in an unfamiliar, featureless desert. These troops came to rely heavily on small, lightweight GPS navigation receivers. GPS-guided bombs and cruise missiles hit their intended targets with precise accuracy. Discus satellites provided global secure communications for all military services using fixed or mobile receivers. DMSP satellites provided commanders and military planners with near real-time weather information that improved planning of air and ground operations. Also, DSP early warning satellites detected Iraqi short-range Scud missile launches so that they could be destroyed in flight. (1991) also saw another momentous historical event, the collapse of the Soviet Union. America's superiority in space capabilities and ballistic missiles, including the new Peacekeeper ICBM, contributed to the end of the Cold War and to treaties reducing nuclear weapons worldwide. Our strategic missile force continues to provide a blanket of deterrence as part of America's national security policy. The Air Force developed MILSTAR, the most advanced and secure communication system ever built. Advanced processing techniques, as well as satellite-to-satellite cross-linking, allowed each MILSTAR satellite to be relatively independent of ground relay stations and ground distribution networks. The data rate of the upgraded MILSTAR 2 was 640 times faster than that of MILSTAR 1. Looking to the future, the Air Force started acquisition of a more efficient and affordable generation of booster, the Evolved Expendable Launch Vehicle, EELV. 2 contracts were awarded, one for a new family of vehicles known as Delta IV, and another for a family of vehicles known as Atlas V. By 1999, America's warfighting dominance in space was even more advanced. The coalition victory in Operation Allied Force in Kosovo demonstrated for the first time in history that a major conflict could be won with airstrikes alone and without a single coalition casualty. By now, GPS had achieved full operational capability with 24 satellites in orbit. Nearly all smart bombs and cruise missiles were guided by GPS right to their targets, day or night, in any weather. Also, navigation and communication satellites were beginning to take the search out of search and rescue. Combat Survivor two-way radios and GPS receivers could now guide rescue forces directly to air crews shot down behind enemy lines. The end of the 20th century brought major changes to how the Air Force conducts space operations. Recommendations by the Launch Broad Area Review expanded SMC's responsibility for each DoD launch and resulted in 36 successful Air Force launches in a row. In addition, recommendations of a space commission made up of experts from the DoD and Congress resulted in SMC joining Air Force Space Command. Coming full circle, the acquisition and operation of military space was together again under one major command.
attack on the Pentagon from the south.
U.S. officials are saying there was no warning.
This is a terrible day.
September 11, 2001, the most massive terrorist attack in history. For America, it was a 21st century Pearl Harbor. These tragic events created a national rallying cry which accelerated America's war on terror. The United States launched Operation Enduring Freedom in Afghanistan. Once again, Air Force satellites and highly mobile user equipment were key to successful military operations. 2002 saw the first launches of the new EELV rockets. In August, Atlas V carried a commercial satellite into orbit. 3 months later, the Delta IV also transported a commercial satellite. EELV is expected to reduce launch costs by more than 30% over current systems and reduce launch processing time from months to only days. During Operation Iraqi Freedom, coalition forces conducted a massive offensive against Saddam Hussein's military. Air Force Space Command's Aerospace Operations Center planned, directed, and assessed daily space activities supporting air, land, maritime, and special operations. Upgraded Air Force satellite systems provided improved navigation, communication, and weather data for military planners and ground troops alike. Allied air planners were able to reduce the time it took to identify and hit an Iraqi military target from about 1 full day during the first Gulf War to as little as 11 minutes during Operation Iraqi Freedom. The early years of the 21st century saw the beginning of a number of new space programs. Systems such as the wideband gap filler and advanced extremely high-frequency satellites will add greater communications capabilities. Space-based radar will provide military commanders with worldwide, near-continuous surveillance and reconnaissance. These are only a few of the major space systems currently under development by the Air Force and Department of Defense. Operating from the new high ground of space has created radical changes in how America fights and wins wars. The mission that General Schriever began in 1954 is now being fulfilled in the 21st century by the people of Air Force Space Command, its acquisition teams at SMC, the launch groups at Cape Canaveral and Vandenberg, the ICBM deterrent forces, and satellite operators located around the world. The United States Air Force has led the way in space and missile programs for 50 years. In the future, the Air Force will proudly continue this legacy as the world's leader in space, the high frontier.